Hello everyone, welcome to AI Anytime channel. In today's video, we are going to build a simple web application to query PDF files. So that the application will help you, query a question over your PDF file and retrieve some kind of information or answers, right? To build this application, we are going to use Pinecone, which helps you with the vector databases, and ChatGPT or GPT-3 or 3.5 as a large language model. And we're also going to use Langchain that will help us do the heavy lifting, before data pre-processing, creating some kind of chains and retrieve the information. So these are the tools and techniques we are going to use to create this web application. So let's jump in. So if you currently see, I'm on Pinecone and it says long-term memory for AI. The Pinecone vector database makes it easy to build high-performance vector search applications, developer-friendly, fully managed, and easily scalable without infrastructure hassles. Pinecone is one of the most famous, I'll say currently it's a platform. Basically, it helps you with a lot of services on their platform, but the most famous one is the vector database. So they have the capability where you can search on top of your documents, that too with inbuilt vector databases and the algorithms that they have. Okay, so it says long-term memory for AI. It's the most used currently in the industry. Okay, and we also have then Langchain, which Langchain is one of the most used library in the last 6 months after the rise of generative AI. Right, nowadays without Langchain, I don't see any application which is powered by large language model. Right, Langchain is like helps you with all the heavy lifting. So if I currently show you, right, let me just make it a present. So you see, this is what Langchain provides. It's an unified library, I will say, that helps you to build AI applications with all these techniques and services. So they have models where you can integrate models directly from Langchain. They have different chains like conversational, retrieval, etc. They have also option of prompts, so you can define a custom prompts and you can use that prompts within Langchain as well. Then they have indexability, of course we have seen embeddings, etc. Then we have agents. Now Langchain combined with multiple agents, so we're calling it agent GPT and whatnot, right? Memory, right? Memory is it's a debatable topic, right? Many of researchers believe that AI don't have a memory, but it has used interchangeably, right? That can be context, and from that context, it kind of looks at what was the previous conversation, that the prompt or the responses that you see, and from those, it kind of try to retrieve the information based on some algorithms like cosine similarity, Jaccard similarity, etc. Right? So it also has the option of memory, right? You have seen conversational memory, etc. You would have seen it on when you have used Langchain. So if you also see, this is how the end-to-end it works. This is not my slide. I forgot his name. I think something like AI Age newsletter. I think credit goes to them for this particular slide. Yes, I think it's AI Age newsletter.io or something. The entire credit for this slide goes to them. But this is how it works end-to-end, guys. You have your data. Now, if you go and ask GPT, kind of chat GPT, that hey, what was the academia result of how many views that AI Anytime channel has. Okay, so ChatGPT will have no idea because ChatGPT has not been trained on those data. Okay, those private data, for example, or even data after 2021 in general. Right now, you have your private data that can be any kind of documents or any across multimodalities of data. You have audio, you have video, etc. You have that data. Will break that data into different chunks and then pass through through first we LLM, and then it gets, so we use some kind of embeddings technique to have the vector embeddings and store in a vector database. So you can see the vector database that has been used here. We are going to use Pinecone. Okay, but there are many open source vector databases natively that you can use. For example, ChromaDB, which is nowadays being very famous. ChromaDB, fast, both on CPU and GPU. And earlier people were using Elasticsearch, for example, and there are multiple techniques where you can create embeddings for your data, and you can store that embeddings in a vector database both natively through an open source and also closed source. So Pinecone that you currently see, it's kind of a closed source. Okay, it kind of, we take the API from there and we store the embeddings on their whatever region of cloud that you are using, that they have on the infrastructure wise. But this is how it works. So you have the vector embeddings, then you choose an LLM to infer into it. So LLM will go and from the inference, they will utilize the knowledge from there, and then they will respond. Okay, so that's how it currently works. So from private data chunking, data pre-processing with Langchain, then you use some kind of embeddings, that can be any embeddings, algorithm or platform or services that you use, and store in a vector database, and then on top of that an LLM inference, and you get the response out of it. So this is basically the embedding space, right? You can see the query, the relevant documents, etc. Then there's a search algorithm comes in, and with semantic search and different similarities algorithm. So this is the high level view of how it currently works in the backend. So you need a couple of things here to build the application. The first thing that we need is API keys, okay, from OpenAI, because we are going to use a closed source model, a closed source language model. We can use GPT 3.5 Turbo, and we can also use ChatGPT API from OpenAI here. So you can do that as well. And Langchain documentation, you can find it here. And then we have this long-term memory for AI Pinecone, right? And you can see my Pinecone console. What you have to do when you come for the first time on Pinecone, you can see my project. I have only one project. Let me click on view all project. Now when you come on this dashboard, you will have view all project. In free version, you will only have option to create a single project. So you can see I already have this project called Langchain demo. So I'm not going to create a new project here. But if you come to this platform for the first time, to this dashboard for the first time, you will see an option here, create project. The button will be enabled. Currently disabled. You can see I cannot click on it because free aux can only have a single project. So I cannot do that. You can see my environment is in GCP free and US West. That's the reason I am currently on free version. Okay. Now, so let's select this project, Langchain demo. When I click on Langchain demo, you can see these are the indexes that I have created. Now you have multiple documents, so you need an index store. You need the index store where you can basically all of your embeddings things will be stored in this indexes. You can see my index name is Langchain demo indexes. It's on US West 4 GCP free. I have a metric here called cosines. You would have heard about cosine similarity, the dot product, the Euclidean norms. If you are not aware about cosine similarity algorithms, please go and read about it. It's very traditional, the most classical NLP algorithms that we have, right? And then we have pod type, which is starter, because we are on a free project. Then the dimensions of it, 1536, that's on a free project. Then we have pods per replicas, total pods. So you can increase the pods also, but it's not available on free version. So we're not going to do that. Now if you click on Langchain demo indexes, you can see it shows a couple of things here. It shows the monthly cost, it shows the vectors because we are on free, and we are looking at how much of the result that we have queried, etc. You can read about this. So what I have done, let me just show the folder. We have a folder called QA tool. So let's start writing some code here. So now what I will do, I'll activate a virtual environment. You can see I have a VENV. Now how do we create a VENV if you don't know? So if you are on Anaconda, that's you use the Anaconda command to create a virtual environment. If you want to do it natively in Python, you do Python -m VENV and then VENV folder name. So in case I already have a VENV, I'm just going to do CD inside it, and I'm going to do CD scripts and /activate. Now couple of CD .. to go to the root directory and clear it, and you can see my virtual environment is activated. Now let's open in a VS Code. So I'm just going to do code dot here, and in code dot, so you can see these are the requirements. You want to build this application, you have to install all these things. So you need the python.env, because we are going to manage the envs from a env file, so we don't expose this to the internet or the end user. And you need python.env to manage that. Then we need Langchain, then we need OpenAI, because this tutorial video is completely closed source. We are not using anything open, no open source. So if you are not interested to looking at closed source based applications, you might not watch this video, guys, to be honest. Okay, but if you want to try, you want to learn that how it works end to end, what are the techniques that we are following, you can look at this video, because most of the things even on the open source will remain the same. Okay, there are a lot of open source model like Falcon, which is one of the most most famous LLMs right now. Then we have a lot of others like Vicuna, etc. For example, Alpaca. You can look at that as well. So we need OpenAI. We have Pinecone client to connect with Pinecone. Then we have tabulate and PDF to image, because we need to work with the PDF files in this case. So we need some kind of library which will help us retrieve the information so that we can create the embeddings out of it. We need Streamlit because we are going to build a Streamlit application which is easy to build. And then we have Pinecone. This is for OpenAI basically. So this is what we are going to use in this video, guys. So if you see, I have a data. Let me just show you the data. So I have downloaded this data, and this data is about, let me just show you. It's a Microsoft annual report. So Microsoft annual report of 2022. I'm going to use this form 10K, like from SEC 10K, NASDAQ. The symbol is MSFT, and I'm going to use this around 100 pages. You can see it's more than 100 pages. You can keep multiple documents as well, guys, to create the embeddings. There are some certain limitations on Pinecone, but I think that should work for at least few PDFs. Now this works fine. Now what I'm going to do here, I'm just going to create an app.py. So let me just do that. So I've just created an app.py, and here in this app.py we'll start writing our code. So the first thing that we have to do, let's import the Langchain thing here. So Langchain, from Langchain.document loader, because we load the files from there, import directory loader. So directory, that should be capital, import directory loader. This basically module will help us load the files from that data folder that you see. This is done. Now we need text splitter. We have to split that, right? We spoke about the chunks, but we have to split that, right, to get the chunk. So from Langchain dot text splitter, and then I'm going to do import character text splitter. You can also do recursive. Please go through Langchain documentation. Langchain documentation is one of the best documentation I have ever seen, in my life, 6 years of this professional career. Okay, the great documentation. They update it like anything, because there's a lot of integrations happening in Langchain. So from Langchain.text splitter, import character text splitter. Now the next thing is, let's have some input. So import OS for env and all. Then we need Pinecone, so import Pinecone. And then we're gonna do from, so we need to import Pinecone from Langchain, that's from vector store. So from Langchain dot vector stores, import Pinecone. You want to use something else, like in previous video I have shown you Vectora. So in one of my previous videos, if you see, I think second last previous video, if you see, it's Vectora. So Vectora has come up with a grounded generation technique, helps you with the hallucination. Please watch that video as well. It will really help you if you are looking to control hallucination. So from Langchain.vector stores, import Pinecone. The next thing is from Langchain dot, we need embedding thing here. So embedding dot OpenAI. We are going to use OpenAI embeddings too, guys. So OpenAI, import OpenAI embeddings. You can also, if you are looking at open source, you can look at sentence transformers, just a starting point. You can look at other embeddings like Alpaca, Vicuna. They have all their embeddings, right? You can have a look at that. I hope you have that computational power to run that as well. So from Langchain.embeddings.openai, import OpenAI embeddings. Now what next we have is the retrieval QA, the chain. So from Langchain.chains, this is going to say import. I'm going to do here retrieval QA, and this makes sense. Now let's use the ChatGPT API, guys. So from Langchain dot chat models. So what are the chat models that we have? Okay, so we have import chat OpenAI. So I'm just going to do import chat. You can see they have Anthropic. So if you have Anthropic, which is a startup, acquired by Google around at 350 million or something, if I'm not wrong. They acquired because Anthropic also has Claude. So Claude is like the competitor of ChatGPT. It's not that good, by the way, but they are kind of improving it. So if you want to use their API as well, you can do that. They have Google Palm. So Google has come up with their generative AI services, right? So Palm. Then we have Vertex AI, from Google again. Vertex AI is a unified platform for your AI workflow, right? That's what Vertex AI does. It's fascinating, right? And then we have OpenAI. So I'm going to use OpenAI here because I have that API with me. So from Langchain.chat models, import chat OpenAI. We need Streamlit here, so import Streamlit as ht, and then couple what else we need. So we need load.env. So from .env, okay, it's excuse me, there's something wrong. From .env import load.env. This makes sense. The first thing that we have to do, we have to initiate this constructor. So load.env, which we define like this. Now we can load all the things that are in the env file. You can see I have an .env file which contains everything. The first thing that we'll do, we'll define our things, okay, the constant that we are not going to change. So let's do that. So the first thing is Pinecone API key. So Pinecone API key, and I'm just going to use os.getEnv, that will take from getEnv file, which makes sense. So you can see the first one is defined. Then we have the Pinecone environment. So in which location? So you can see here, let me just show you quickly. You can see my environment is this one, US West 4 GCP free. If you want your API keys on Pinecone, you have to come on the left hand side and you have to click on API keys to get that. I'm not going to do that here because I already have. Okay, so Pinecone env, this makes sense. os.getEnv, and now the OpenAI API keys, pretty much straightforward. So OpenAI API key, and this goes like this. So now here we have kind of defined the constant that we are not going to change. Okay, because this kind of API key will not change it regularly, so we have defined that in our app. Now let's to Langchain, to use the chat OpenAI, we have to define the API key. So how do we define? OS invar es, this makes sense. And OpenAI API key, this will be OpenAI, just to mapping it. So therefore we have mapped. So we are done with our API thingy here, guys. Okay, so now this makes sense. Now what I'm going to do here is I'm going to just define a couple of functions. The function will help me basically with preprocessing, or with preprocessing and embeddings, etc. So let's do that. So the first thing I'm going to do, right, define doc preprocessing. So I'm defining a function preprocessing, and here I'm going to just use Langchain. So loader, and I'm going to use directory loader, that we have the module that we have imported from Langchain on top, and inside this I'm going to write couple of things. The first thing is data folder. So our data folder is nothing but just the data. So I'll just do write like this, and inside this, the next thing is, let's define something like, we only need the PDF extension, so globe. So that just a minute, and this goes like this, that we only looking at the PDFs, we're not looking at something else for now. So this goes PDF, and this is okay. So we are only looking at the PDF extension. Now the show progress, so the entire step, right, you can kind of track this in terminal. So I'll just write show progress, and show progress, I'll just keep it true for now. So this makes sense. So now we have a loader. So in that loader we have a couple of parameters. The first parameter is globe, and which looks at the PDF extension. Then we have this show progress, which is true. Now loader is done. The next thing that we're going to do is, I'm just going to load that in a docs variable, loader.load. That's it. Now this will load, and now the text splitter. So let's define a variable called text splitter, and I'm going to use character text splitter, and inside this again I'll just pass a couple of things here quickly. So the first is chunk size. What should be the size of your chunks that you are creating, right? The words that so for that I'm going to keep 1000, which is very standard. So chunk size 1000, and the overlap. So for now I'll not have any overlap. Okay, so let's call it 0, but you can keep it, you can play around this number, guys. Okay, this completely depends on some kind of expertise in with Langchain, etc., right? The way you pre-process your data, right? So chunk overlap is done. Now what I'm going to do, I'm going to use a variable called docsplit. So let's define a variable called docsplit, and in this one I'm going to use text splitter, which is a variable that we have defined on top. You can see here text splitter, and then I'm going to use split module. So text splitter dot split document, because it's a document. If you have a text file, you can go ahead with the text split text. Now split documents, and in that I'm going to pass the docs. So the docs you see here, which contains the docs that I have, right? And now I'm just going to do return here. So return doc split. The pre-processing function is completed. So what are we doing in this function? we have a function called doc preprocessing. We have a loader loading the file, looking at the extension whether it's PDF or not. Then we have stored that in a docs variable. Then we use character text splitter, where we're defining the chunk size and the overlap, and then we split it, combining both text splitter or split documents on top of that docs, and we just return that doc split. So that's what we are doing with this doc pre-processing function, guys. Now the next function that we're gonna write is the embedding DB, embedding thingy, right? So let's define that. So embeddings, let's call it embedding underscore DB, and in this case here I'm gonna use Pinecone, OpenAI embeddings and all, right? So this is what I'm gonna do here. So for that, so let's first define a variable called embeddings, not embedding DB, and in this embeddings I'm gonna use OpenAI embeddings. So I just define that and we store that in a variable called embeddings, and after that we're gonna initiate the Pinecone. So Pinecone.init, and inside this we have to use the API key of Pinecone. So API underscore key, you can see the variable has been suggested, and this is nothing but our API keys, which are like Pinecone API key that we have defined on top. And after that, the environment. So our environment was, you can see, Pinecone env. So Pinecone env. Now we have initiated the Pinecone module here, the instructor. So Pinecone.init, and we have the embedding. So the next thing is we need the doc split. So I'm just going to call that function. So just let's define a doc split, and let's use the top function. So doc split is nothing but it's doc preprocessing function. So we have to call that function here. So I'm just calling that function. Now it has doc split, and now I'm going to define a DB called doc DB. And in this doc DB, what I'm going to do here is Pinecone dot from document, from documents, and again in this let's write couple of things. The first thing is doc split, okay, and we need the embeddings on that. Then other thing is embedding, which is I think we have embeddings, and our index name. So our index name, so our index name will be, let's see what our index name. So our index name is this. I'm just going to copy it here. So let me just copy this, Langchain demo indexes. Now this makes sense. So docdb is also done. Now let's return the docdb. So I'm going to do return docdb. So this function is also completed, guys. So this function, now here's the thing, because we are going to work with a Streamlit application, we don't want these embeddings to be created every time if documents are not being changed. So suppose if you have 5 documents, PDFs in this data folder, and for the first time when you run this application, it will create the embeddings for you. Now we don't want to run that every time if the documents are not being changed or being updated. So for that, let's use a decorator in Streamlit called cache resource. So what I'm going to use that st.cache. Yes. So this will basically help the cache that resource, right? That's basically a Streamlit decorator. Now the next thing is we're going to write again the last function, which is again the retrieval QA chain that we need from Langchain. So for that, let's write retrieval. Maybe you can write something. So not retrieval. So retrieval real answer, and that I'm going to pass query inside it. The query will take from Streamlit app, and here I'm going to write QA, and in this QA I'm going to use retrieval QA chain, and inside this, okay, not retrieval QA, I think it's retrieval QA from chain type. So retrieval QA dot from, yeah, now this makes sense. Now in this I'm going to write the first thing is to pass the LLM. So our LLM, so I think we have to define that LLM, guys. So on top, let's define that LLM. So our LLM is nothing but chat OpenAI, and our docdb. So let's bring that as well. So docdb is nothing but we'll use that function, so called embedding db. That's it. So now we have defined on top. Now we can use here LLM equals LLM, and inside this I'm gonna use a chain type called stuff. Now there are many other chain type. You have map reduce, you have stuff, you have a couple of others as well. In Streamlit you can have a look at as well. So stuff and chain type is stuff. Then we have, let's define a variable retriever, and in this retriever I'm gonna use docdb dot retriever as retriever, docdb as retriever. Now we're gonna use query equals query, and I'm gonna use result variable which will store the result, qa dot run, and I'm gonna pass this query. That's it, and we'll just return the result. So just gonna write return result. This makes sense, guys. So what we have done so far, we have three functions. First does the pre-processing, second is the embedding function, third is the retrieval QA chain which combines language model and your embeddings with a chain type. That's what we have done so far. This is the standard process whatever LLM you use, either it's an open source or a closed source model. The end-to-end flow remains the same. Of course, you can define custom prompts, you can use context, custom prompt question, etc., and you can use as a quarks or arcs, right? You can do that as well. But the most of the flow remains same, guys. Okay, so let me just remove this. So return result. Now what I'm going to do, I'm going to write the function, Streamlit function here, or the Streamlit code. So let's write the Streamlit code. So I'm going to first st.title, Streamlit title, question and answering. So it's answering app powered by LLM and Pinecone. This is what I'm going to do. Title and then text input, and our text input is nothing but let's have a text area, guys, or you want to take text input. Let's have a text area maybe. So let's have a text area, or let's have a text input because question will not be that long, right? So text input, and I'm gonna write, ask your query. Ask your query. We can have this. Now here, so if let's have a button called st.button. If st.button and that button is ask query, and inside that now we'll check we'll put a condition there. Don't execute the below code if the length of text input is 0 or that, right? So if length text input is greater than 0, then you execute this code, guys. So now we can have execute this code, right? So for that, let's have st.info first, info message like your query and your query text input. This is good. And now we'll have an answer where user function. So we have to use the retrieval answer function, guys. So in answer we'll have retrieval answer. I'm gonna pass text input here, and that's it. I'm gonna use st.success, and in st.success I'm gonna use answer here, and we have to use if name equals main. Just gonna use main here, guys, by the way. So main, and we are done with our code, guys. So we have written this code. You can see, let me just give you a walkthrough of this entire code base and the folder directly. The first, you have to create a virtual environment. Now you can see I have a virtual environment, then you have a data folder. Inside that I have a single file. You can keep multiple files. You want to query and you want to create a chatbot, maybe, for example. So this will work for chatbot as well. Maybe you can use a memory here in the retrieval answer. You can also use conversational chain there also as well. From Langchain, we have an env file which kind of stores all the API keys and environment. Then we have an app.py and a requirement txt. So in app.py, first imported all the required dependencies and modules. You can see it over here. Then we have defined that API keys. Okay, we are loading it through load.env. We have a function doc preprocessing. We are taking only the PDF files from the data folder. We are using character text splitter that will split that basically on the chunk size of 1000, and then we are using embedding db. We created a function, by the way. Now you just OpenAI embeddings 002, and we are storing it in embeddings variable. Then we are initiating the Pinecone, where we are passing API keys and your environment. Then we are splitting. We are having a variable called doc split, which uses the function doc preprocessing. Then we are using Pinecone here, guys, to save the embeddings in that. On that, here you can see on the dashboard, right? And now we are using LLM chat OpenAI. We are using ChatGPT API here, guys. So LLM equal to chat OpenAI. Then we use docdb embedding db, and then we have a final function called retrieval answer, which kind of uses the retrieval QA, the chain type of Langchain, passing the LLM using the stuff chain type. We have a retriever which uses the embedding from docdb as a retriever. Then we just use the query and run it, or run the chain on top of that and return the result. Then the basic Streamlit thing is there, right? So we have a text input, ask you a query, h.info, answer, etc. This is what we have done here, guys. In this code, this is what we have done. Now let's run this code, guys. So how do we run this? I'll come over here. You can see already I have my virtual environment activated. I'll just do streamlit run app.py. Let's do that. So app.py, this is what I'm doing. I'll hit enter and I'll run this. It says name load is not defined. So let's see, load.load. Oh, okay. It's not load, it's loader. So let me just make a change here. Loader.load, and I'll do a rerun. So it will take a little time, guys. I will stop the video and I will start once it is done, because it has to create the embedding and all, right? So now you can see, we see an interface says question and answering app powered by LLM and Pinecone. This is not a chatbot, guys. This is a search tool. You can call this a search tool. I see many people creating this kind of interfaces and calling this a chatbot. If you want to use a chatbot, please use this htchat in Streamlit chat. It's a good library created by, I think, yes. Okay, and credit goes to him, okay, for creating this beautiful library in Streamlit. You can see this is the chatbot interface, now, where you can ask follow-up question. You can integrate with a lot of other, smaller sub components, like you want to open a calendar, you want to email something, file, API, etc. You can do that, right? That's called a chatbot, where you have a follow-up question, some kind of contextual, capabilities. This is more of a search tool, where you have a query, you want to retrieve some information. This is a question answering tool. This is not a chatbot. So this is the interface you see. Now this is the document that we have, Microsoft annual report. What kind of question we can ask from this document? Let's ask a question. What was the fiscal rate for 2023? Something like this. Let's ask this question and see if it can retrieve the information from that document. Yeah, you can see now. This is a question that I haven't read that paper. I haven't read that entire document. I just asked the question and thought that information will be there or not. So this was our query. What was the fiscal rate for 2023? And the answer that you see, the context does not provide information about a specific fiscal rate for 2023. It does mention the government fiscal framework, including a spending cap and targets for primary budget surplus, but it does not provide a specific. Let's make it 2022 and see. And that's how, right, when you use Pinecone on this kind of language model, it helps you control the hallucination. But it helps you control. If you use the open source model, they hallucinate like anything, which makes sense currently. They will improve it over the period of time, but it's okay. I'm asking the question again here, guys. What was the fiscal rate for 2020? I've changed the question and see if I can generate it. So you can see it has nothing to do with that, right? So now let's go back to the document and see what kind of question we can ask. I'm just looking at what question I can ask. Let's ask what was the result of TCGA, something like this. Okay, I just want to try what was the result of TCJA. Is it something that I'm searching? Now this is my query. What was the result of TCJA? I'm looking at if it can generate. So you can see here, right? The result of TCJA was that companies like the one mentioned in the context are required to pay a one-time transition tax on deferred foreign income, right? Not previously subject to US income tax. It retrieves the information, guys. It is able to retrieve the information from the document. You can see that how simple it is, right, to use Pinecone, which provides you vector databases, the search, etc., and you combine that with a language model, for example, ChatGPT, Anthropic, Palm, etc. Any that can be anything. You can also do it in the open source as well, right? So let's ask one more question and see if you're getting something. It's able to control hallucination, at least on some extent. It's able to control that. Let me ask a question. What is the document all about? What is the document all about? I'm asking this question. I'm seeing some kind of ability of knowledge that this language model possesses, right? Based on the context provided, it is not clear what document is all about. The text only repeats the same heading, part 1, 4 times. Could you please? So it makes sense, right? I was just trying to check the knowledge. So if you have documents uploaded, can it use some kind of knowledge mechanism to find out what this document is all about, right? Now let's see. What is partner program? Let's ask this. Microsoft Cloud Solution Provider Program. Okay, partner program. Tell me about partner program. So I'm asking this, and let's see if you can retrieve some information related to partner program. Okay. So just to help you understand that Pinecone has limitations also on the number of hits. So the number of API endpoint requests that we are making. So Microsoft has several partner programs. You can see that, right? A very concise answer, that very summarized manner that we have received here. Partner programs that enable systems integrators, managed service providers, cloud resellers, partner, etc. You can also have a look at source citation, guys. If you want to do that, you can also do right from source document. You can have a look at that. Please watch my previous videos. I have shown in some of the videos that how you can also get the citations from which document this information has been retrieved, right? So that's all I wanted to create in this video, guys. LLM and Pinecone. So basically a vector database plus a language model that can be open source, closed source, depending on the infrastructure that you have, right? I also have created a YouTube video. Let me just show that quickly to you. Now where I have explained how to use Langchain LLM. Okay, so if I open your channel.
Welcome.
So you can see a lot of videos related to large language models. So you can also have a look at Vectra, which is an alternative of Pinecone. Okay, and then we have Langchain LLM. So it's a language model, not that large, okay, but you can have a look at that way as well. Then we have Scikit LLM, then a lot of other models and videos that you can find on my channel, guys. If you want to have a look, you want to explore, please do that. So this is on the app, and the code will be available on the GitHub repository. That code base that you currently see it over here on AI Anytime's GitHub repo. I hope you find this useful. So if you like the content, okay, please give us a thumbs up, and if you haven't subscribed the channel yet, please do subscribe. And for more such large language model and generative AI based videos in future, please share the channel and also the videos to your friends and to peer. Thank you so much for watching. See you in the next one, guys.